it's time for the joke of the day. But before that, I'm going to give you a little pre-notice. We're going to talk about point slope form today. We are doing lesson 4-7, point slope form. You'll know you're on the right page when you see those cute little kittens up at the top. Kittens available. In our joke of the day, what did the horizontal line say to the vertical line? Anyone? It was nice running into you. That's funny. All right, on to point slope form. Objective, we're going to graph a line and write the linear equation using point slope form. You can use point slope form to represent a cost function, such as the cost of placing a newspaper ad for adorable kittens. If we know the slope of any line, which we know to be represented by m in slope-intercept form, I don't want you to get this confused with slope-intercept form. This is point slope. So we need, for point slope, we need a point, x, y, and a slope, m. These are the two things we need. So if you look at point slope form, it comes in this form. It's y, which is our variable, minus y1, which is our point that we're working with. That was minus, not equals. Sorry. Y minus y1 is equal to the slope times the change in x. Now this x, this first x, is our variable that stays in the equation. And the second one, x1, is the value that we find in the point that we're given. Let's look at example 1 and see how this works. Write an equation in point slope form for the line with the given slope. Slope equals 5 halves. And it says we're working with the point -3, 0. So let's plug those two pieces of information into our equation. Remember that we have the first variable as our y. The second, y1, comes from our point that we're working with. So that's y minus y1. That's equal to our slope that we were given, 5 halves, times x minus our x value, minus -3. So if we simplify this quickly, we can see y minus 0 is just y. We have 5 halves times x minus -3, which is plus 3, of course. And here we have our point slope form. Let's do part B quickly. Part B says our slope is -7. And our point is 4, 2. Plugging that into our point slope form, we're going to take that 2 value, y minus the y value, is equal to our slope times x minus the x value. Let's do check it out 1 and 2 and come show those to me to make sure you've got them correct. We're going to leave the equation in point slope at this time. So do check it out 1a and 1b and come show those to me so I can make sure you're on the right slope page. Example 2 says, now we're going to graph the line described by the equation. So we're going to extract some information. And example 2, part A, our equation is y minus 1 is equal to 3 times x minus 1. So just working backwards from example 1, we're going to take out that information, which is quite pertinent to what we're going to be doing in graphing. We know that our slope is located here. Our slope is 3. Now the point xy is a little trickier. Remember, it's y minus y1. So if I see a minus sign here, that means this value is positive. So our y point on our line is positive 1. And then that's m times x minus x, 1. So what do we see here? Again, we see minus that positive value, 1, 1. So as the equation reads minus, we know our x and y are positive. So we're going to go over 1 and up 1. We can plot that point quickly, and then we can use our slope, which just is a map telling us what to do from there. Our slope says rise 3, run 1. So we're going to go up 1, 2, 3, and we're going to go over 1, and that is telling us where the next point on the line goes. Let's do check it out. 2A and 2B showing all work and graphing, and then please show me your solution. Show me. So in example 3, what we're going to do is write the linear equation in slope-intercept form. We're going to write in slope-intercept form. But we're given a point again and a slope. We're given the slope -4 with a point of -1, -2. Okay, so let's start with what we know. We know that our point slope form is where we need to start. So let's just write down a quick memo, what's going on there, and start to substitute values. So y1, here's the tricky part. It's y minus y1, y minus -2. You guys can see that's going to turn into +2. We're going to take our slope, -4, and it's x minus -1. Keeping very close eye on this. This turns into y plus 2 is equal to -4 times x plus 1. Well, we're looking to put it into this form. That means we need to isolate the y. Before we do that, we want to simplify the right-hand side. We're going to distribute the -4 to both of our terms. -4 times x, -4x, -4 times 1, -4, and we have y plus 2 on this side. Isolating y means we're subtracting that 2 from both sides, and we end up with y equals -4x minus, hang on, we got -4, -2, we have -6. You guys can see we've done this before. This is just as quick and easy to sketch a graph. We know that our y-intercept is at -6, so we plot that point first. That is our b value. B comes before M in the alphabet. So we plot the b, and then we use our slope, -4 over 1. Now, a good time for this conversation. Can we also do +4 over -1? There's a hint. Your answer is in the circle at the bottom of the page. Yes, we can. So because we've run out of space down here, let's do this. Instead of going down 4 to the right 1, we could go up 4 and to the left 1. That will still give us a negative slope. So we're going to go up 1, 2, 3, 4, and we're going to go back 1. You can see if we started right here at this point, we went down 1, 2, 3, 4, and over 1. So we know we're on the right track. We've got a slope with a negative correlation, and we have graphed correctly using the y-intercept and the slope. Part B looks like this. What if we're given 2 points, 1, -4, and 3, 2? We don't have the slope, but we do have 2 points. Well, you remember our slope formula. Slope is equal to the change in y, y2 minus y1, over x2 minus x1. So we need to quickly calculate that if we're asked to put this data into point slope form. So I'm going to take the positive value first, 2 minus negative 4, seeing that I just wrote that as 2 plus 4. And because I started with 2, I have to start with 3 in the bottom for the x's, and that's 3 minus 1. Simplifying our slope, we get 6 over 2. We get a slope of 3. Now we want to put that into our slope, point slope form. I always write that out because I like to remember. That helps me remember. I'm going to plug my 3 in for m, and I can choose either one of these points. I can choose point 1 or point 2. The reason I like point 2 is because there's no negatives to remember. It's up to you. So I'm going to plug in my y value. I'm using 2. That's this guy right here. I'm going to plug in my slope that I calculated, and I'm going to plug in my x value. And we have our equation in point slope form. Well, the whole premise of example 3 was to put this into, this is point slope. They want us to put it into slope intercept form. I'm just going to write MB to shorten that up a little bit. So let's remember what we needed to do there. We're going to distribute the 3 and simplify on the right-hand side. Check my math. Y minus 2. We're going to isolate the y. That means we have to add 2 to both sides. And y is equal to 3x minus 7. Slope-intercept form. Slope is 3. But what this told us is, outside of the information that we started with, we didn't know the y-intercept, and now we do. Y-intercept. I would like you to check it out, problems 3A and 3B, and part of your grade is showing me all of your check it out problems in lesson 4-7 today. So please show those to me so you can get your points checked off. So in example 4, it says we're going to use 2 points to find the intercepts. In example 4, it gives us the points for 8 and -1, -12. And what we want to do is find the intercepts of the line. We're going to write this equation in slope-intercept form. In order to do that, we need to calculate our slope first. I'm going to use -12 minus 8. Therefore, I have to use -1 minus 4. And if I simplify that, I get -20 over -5, which simplifies to a slope of 4. I'm going to plug in one of these points. Again, I choose the one with the least amount to remember. I'm going to put it into point slope form. It is y minus 8. That's equal to the slope that we just found over here times x minus my x value, which is 4. We're going to simplify this, 4x minus 16, and I'm just going to add that 8 at the same time. Y is equal to 4x, that's an x, minus 8. Well, in using intercepts, as we understand, we can do this quickly and easily. I'm going to allow y to equal 0. That means when y is 0, I'm finding my x-intercept. Well, when y is 0, I get 4x minus 8. Solving for x, I get 4x. I'm going to add 8 to both sides, divide by 4, and I get x equals 2. I'm going to do the same thing for my y-intercept. I'm going to allow x to equal 0. Whoa, Pam, slow down there. Too many equal signs. Minus 8, there we go. So y is equal to 0 minus 8, which is just -8. When y is -8, I found my x value to be 0. So we can graph these quickly and easily. My x-intercept is 2, using intercepts, and my y-intercept is -8. Please do check it out, number